They would have to know the private key.
Anyone who wants a public key or certificate of user A needs to now know the private key of user B, which
right.
user B only knows. So basically you are sharing or sending your public key certificate only to user B. Nobody else on the channel can look at it. Okay, so this is more secure. Alright? Okay? Any question? So I think the picture shows all the different colors, right? So I'm encrypting this whole thing. So this is what's a message, encrypted the private key of A. And to decrypt this, you need a public key, right? So the public key certificate is meant for that. And you encrypt the whole thing with the public key of user B. So it's only user B who knows its private key can decrypt both of them. Right? So it can extract both of them by this outer layer of decryption. Once it decrypts this, both are exposed. Right? So now, how does user B extract the public key of user A? Once you decrypt, you get these two things, right? So how does now the receiver go ahead with the decryption process?
Decrypt the public key, right?
Huh?
Decrypt the public key,
Decrypting
right?
the public key of A, but how does it know the public key of A?
Because they send a certificate.
Certificate. So between the two, what you would do first?
You gotta verify
Right,
the
the
certificate
certificate.
first. dude.
Not verify. You don't know the public key, right? So what you should do, you should decrypt the certificate with what?
The private key of
B.
B.
Not public key.
The public key of the certifying authority. Right? You know the public key is nothing but the public key of A encrypted with the private key of the certifying authority, right? So you want to extract the public key of A. So you want to decrypt this with what? You know this is the public key of A encrypted with the private key of the certifying authority.
Okay.
So you need to decrypt this with the public key of the certifying authority and extract the public key of A and use that to decrypt this. Right? So this is the first decryption. This will be the second decryption with the public key of the certifying authority, and then this will be the third decryption with the public key of user A. Okay?
What is the second one? Is
The second one, you know what is the public key certificate? Public key certificate of user A means it is the public key of A encrypted with what? The private key of the certifying authority. So I need this, the inner one, the public key of A. So in order to get that, I need to be able to decrypt with the public key of the certifying authority, so that I can extract the public key of user A. That's the second decryption. So only once I do that, I can get to know what? The public key of user A. So I can use that to do this decryption. Without that, I cannot do this, because I don't know the public key of user A. Or I may know it, but I want it to be a certified one, so I want to make sure that I use a certified public key rather than just what I think is a public key. Okay? Any question? So like the KDC thing, we can also have a hierarchy here, and that's what I show here. There may be one or two places there's a typo, but let me show it here. Doesn't have to be. So I posted some more videos on number theory, RSA example, and how to run the socket program, so we can go through them. make sure there are one or two typos here, which I will show you what it is. So let's do this hierarchy. Wherever this, if somebody has the notes, make this to be CA1. So it's not just CA, it's just CA1. So this place and this place, it should be CA1 rather than just CA. Why? Because we have a situation here where user A obtains his certificate from CA1. Okay? But user B, with whom A wants to communicate, doesn't directly trust CA1. Right? So, in that case, there has to be another certifying authority, CA2, which user B trusts. And CA1 has to send user A its own certificate. You see what I mean? So, user A gets his certificate from CA1, right? And CA1 will have its own certificate that it gets from CA2, another certifying authority. And user B only trusts that guy. Okay? So if user A wants to send a message to user B, what it has to do? From a big picture point of view, the message encrypted with the private key of user A, right? And of course it will be further encrypted with the public key of user B. Now, along with this, right, I need to send the public key certificate of what? Of user A, right? But the public key certificate of user A is signed by whom? CA1, right? This is certifying authority. It's not sufficient to just send like this we did before. Why? User B doesn't trust CA1, certifying authority 1. So it has to, we have to use what? The public key certificate of CA1. Well, you see here I told you that in order to decrypt you have to use what? You have to decrypt the public key of, use the public key of with which one? CA, right? The public key certificate of, you have to use the public key of the certifying authority to decrypt this and extract the inner public key in the previous case, right? User B can do this because it trusts the certifying authority. So it just goes ahead and uses the certifying authority's public key. But if user B doesn't trust the public key of the certifying authority, it has to go through what? It has to go through a certificate of this public key of the certifying authority. And that's what we are doing here. Because user B needs the public key of user A, right? And public key of user A is inside this. And it is signed by CA1. But in order to decrypt this, user B needs to use the public key of CA1. But user B doesn't directly trust the public key of CA1, right? So it needs a public key certificate of CA1.
So CA1 got to get a certificate from CA2?
Right. So it needs to get a certificate from CA2, and that's what is this. This is signed by the private key of CA2. And user B trusts CA2. Right? So user B can use directly the public key of CA2 because user B trusts CA2. So what it has to do? It has to go through, which is the first decryption you will do. This is the first decryption. You have to decrypt the public key certificate of CA1, extract the, of course you have to decrypt first, so right? So after you decrypt this, you go through this. So decrypt this one using the public key certificate, public key of CA2, extract the public key of CA1 from this, use that public key of CA1 to decrypt this, to extract what?
The private key.
The public key of user A, right? So once you extract the public key of user A, decrypt this with the public key of user A and extract the message. Alright? So you go through one more layer of decryption. You first do this outer layer of decryption with your private key so nobody else can decrypt. That's simple, right? So once you extract this, the inner thing, You cannot use what? The public key of CA1 as it is, that like we used before. We cannot use the public key of the certifying authority who signed for the public key of user A because you don't directly trust that certifying authority. You trust only somebody else, and there has to be hierarchy. So this certifying authority has to have its public key certified by someone else whom user B trusts. Clear? So normally what happens is when user A gets its certificate from CA1, CA1 also has to send its certificate, CA2, right? That it gets from CA2, isn't it? Because if I want to send a message to B, right, I need to send all these things from A to B, right? So the certifying authority, when it signs for this guy, it has to also include its own certificate in what it is sending to CA, to user A. So depending on the need, user A has to know whether user B directly trusts CA1 or it trusts CA2. User A has to decide whether to include this one or not. If user B directly trusts CA1, there's no need to include this one, right? If user B doesn't trust CA1, then user A has to include this one. So user A has to kind of make at least a guess whether user B will directly trust CA1 or not. Clear? Okay? Okay, so we saw this. So now there are, this again terminology. There are three classes of this digital certificates or public key certificates. The first two classes, 1 and 2, are called end entity certificates. So what it means is it's assigned to individual users. Okay.
Say that again.
Individual users. Okay. So class 1 is to assign to someone who wants to send a digitally signed email. So if I want to send an email and I want to encrypt it with my private key as my digital signature, right? That's what we do. We encrypt where we use. I encrypt my message with my private key, right? So this is where we need to use the public key to decrypt, right? So if I want to send an email and I want to encrypt that with my private key, the receiver has to decrypt with my public key, right? And the public key is not directly usable as a public key, it has to get my public key certificate. So if I want to do such things, I need to get a class 1 public key certificate. Okay? So that's what it means. So if you want to use it for like individual purposes, you want to verify an identity of an individual that you get through email, use a class 1 certificate. Class 2 is for signing software. So we discussed this last time. So if you're downloading some software from the internet and you want to make sure it doesn't have any virus or it's authentic or something like that, so you prefer it to be signed by a trusted party, right? So again, the software should accompany itself with a certificate. Like you see all the cases here, even the first case. If I send an email and the receiver doesn't know my public key certificate, I have to include my public key certificate. That's the purpose of what we saw before, right? When I send a message and the receiver doesn't know how to decrypt it because it doesn't know the public key certificate, I include my public key certificate, right? So in this case, if it's an email, this will be a class 1 certificate, right? This is class 1, isn't it? So likewise, if I download a software, the software has to accompany with itself what? A certificate. Because if the receiving side downloads a software and before it installs, it wants to make sure the software is kind of authentic, right? So along with the software, I need to be able to, so the software, the code or executable, whatever, will be accompanied by a public key certificate. Okay? And this public key certificate will be signed by whom? A certifying authority, right? Which the receiving browser or whatever the machine has to trust. Right? So like very sign or any certifying authority who can sign for software, the browser has to be configured to trust those certifying authorities. Okay? So you accompany the whatever the message or the software with the corresponding certificate. So in email case, like we see a little later in PGP, we accompany the certificate, the message along with the certificate. Like that, we accompany a software along with the certificate signed by a certifying authority. Okay? So this is a class 2 certificate that we issue for software. Okay? Now, now in certain cases, you may be wondering, again like this guy signs for this guy, right? So it signs a public key for user A and kind of vouches for it, or makes everyone to use that as a public key certificate. So as I said, but someone has to give the authority for CA1 to sign for all its users, right? So like this, you may sign for several other people, right? So to certify itself, you have to be certified, like what it is, like CA2 does. Okay, so CA2 is higher up in the hierarchy. It gives CA1 the authority to sign the public key of all these different users, right? So CA1 in this example is said to possess what is called a class 3 certificate, because it can, this certificate that CA1 uses, not this one is a class 3 certificate. This is a class 1 certificate, right? This is just for user A. Isn't it? This is class 1. Whereas this is a class 3 certificate, because this is the certificate for a certifying authority. Is that clear? So that's how you can understand the difference between these three classes. Okay, so the certificate for an individual user is a class 1 certificate, the certificate for a software is a class 2 certificate, and the certificate for a certifying authority is a class 3 certificate. Okay? So this is a class 3 certificate. Whereas this is a class 1 certificate. The certificate of the individual user A, the class 1 certificate. Is that clear? Any question? And there's a picture that I used to illustrate the root is like the big CA from which these two CAs can receive the certificate as the class 3 certificate, and they can issue the certificate to end users. End users means end entity, either the software or the individual users and things like that. Okay? Any question? Okay, so have you ever come across this term Kerberos? Have you come across a term called single sign-on? Right, portals. Right, what do you do with that? SSO is called single sign-on. The idea is, if you say log into a network, right, and you have several servers over there, say a file server, a web server, a database server, blah, blah, all these different servers. If you want to communicate with each of the servers using your password, you have to send your password several times, each of them get authenticated, and then they let you to access.
Remote desktop?
Huh?
Remote desktop?
What is that?
Remote desktop?
No, it's not remote desktop. So I think Hotmail, Windows Live, something, they have this feature. So which means you could, if you somehow configure all your, say, what is that, credit card, your utility bills and all those things, right? So you log in once and make the payment, and it will pay, it will detect the money from your account and everything, and you pay. Rather than like you have to remember the password to pay for your electricity bill, and then a password to log into the phone company website and pay your phone bill. log into something else and pay something else. So instead of that, you bring everything into one umbrella and you log in once and you just select I want to pay my electricity bill and you pay. And you want to pay this and you pay. So it's a single sign-on kind of thing. Okay? So that's the idea here we are going to use. Here we will use a notion of what's called a ticket. So you first get authenticated with a server and get a ticket from the server. And the ticket is of course time validated. It's valid only for a certain time. We don't want to have what's called a replay attack and all those stuff, in the sense that someone who gets access to the ticket should be able to use it after a while. So the ticket has an expiration date and all those stuff. So, but the idea is, using that ticket, you can authenticate yourself to the different servers. So you don't have to go through a very formal kind of password-based authentication every time you want to use the different servers. The ticket itself will serve as an authentication for you to use those services. Okay? So that's the idea behind what's called Kerberos. Okay? And let's go through this flow chart. Again, once you go through it, the first two stages, third one should be kind of automatically similar. Okay? So, as you see here, to start with, the client is really the machine. Okay? And the user is the one who is working on the machine. So the user wants to use some services. Okay? So the user sends its ID to what is called an authentication server. Okay? Now notice that I didn't send the password, I just sent my user ID. Okay? So the password, the user knows his password, so this side you know the password. And the authentication server has a database where it stores the password for every user. So both sides know the password. So that's the underlying assumption. Okay? So just when you send the user ID, what happens is the authentication server kind of generates a secret key based on the password. Okay? So there is a kind of algorithm that generates you the password or generates the user secret key based on the password. Okay? So the password is a key, seed for generating the secret key. So if someone fakes as a user ID, they have to also know the password. So no one can easily spoof the authentication server, because this secret key is generated based on the password, not the user ID. So if you notice here, the authentication server sends these two things. It sends the what is called a client TGS session key encrypted with this user secret key, and it sends this ticket granting ticket encrypted with this TGS secret key. So these are two things, right? So let's see one by each of them. This client TGS session key is the key that the client has to use to communicate to the next level of server called the ticket granting server. And this is encrypted with the user secret key, which is supposed to know only to this user, provided he knows his password. If the user doesn't know his password, he cannot derive his user secret key. So both ends independently derive this user secret key based on the password that they know for each other, like user ID accompanied with the password, right? So both sides know the password. I think I would really prefer other classes, because if some of you take my other classes, I really project on the board and I can easily write. So if this picture was here, I could easily write it. So you have the client.
Dr. May, you said you like this class because the board long.
Yeah, but if you have figures like this, what you can do?
What you can do? Put it in the mirror over here, we can see it.
Mirror?
Put it in the mirror.
Yeah, but there's no mirror.
I guess that is the.
I don't know who designed this. Maybe you, I don't know, even if you want to present, you have to always look above and, right? So the implicit assumption is what? Both sides have a password. Like, both sides know the password. Okay? So I can derive locally what? The user secret key. From this, I can derive my user secret key, and I can derive my user secret key based on the password. Right? So when that guy is really sending what? Is really sending the client TTS session key, right? Encrypted with what? Encrypted with the user secret key. Isn't it easy for the receiver, which is this side, to decrypt this? Because the user secret key can be derived from the local password, right? So unless I know my password, I cannot derive my secret key, user secret key, right? So, do you get what I'm telling? User A, the client sends its user ID to the authentication server as a first step. And both sides should know their password, which means the password for the user ID, right? So as a user, I should have a password to log into this network, right? So that password I'm not sending in plain text or even in ciphertext. What I'm just sending is my user ID. But my password is known to the authentication server. It has its database. And I know my password. If I'm a valid user, I know what my password is. Right? So there is an algorithm, of course, as part of Kerberos to derive what is called the user secret key from the password. That algorithm is available at both sides. Okay, so if you run Kerberos, there is an algorithm that derives you the user secret key from your password. So with that assumption, this guy can derive the user secret key from the password it knows for me, and the same password, if I know